Generics is when we use a placeholder instead of an actual class type when we're defining our classes. We say that the class is a class of generic data type. The class type is then determined when the object is instantiated. We already have experience with this when we were working with the ArrayList class. The ArrayList class is a class of generic data type. The type of ArrayList was not determined until our code was compiled. In this example, we create an array list that will hold only name objects. Here, in this example, we create an array list that will hold graphic cars. The ArrayList class itself is an example of a generic data type, and the type of entries an array list will hold is determined when we compile these statements. We can do that with any number of classes. Let's take this class, SumClass. It has a specific type of data it works with, strings. It has a private data field string. The constructor has a string parameter and initializes that data field with that parameter. It has an accessor method to return that data field and a mutator method that accepts a string value and then sets the data field to be that value. This is great if we only want to work with strings. But let's say that we have some very intricate logic here that we really like and want to use with any number of data types. We can make it a generic class. Well, let's say that we have some very intricate code in our class, SumClass, and we want to be able to use that with other types of data, not just strings. We could create a class with a generic data type. We would start out by using the class name and following it with an angle bracket T and a closed angle bracket. Now, in our examples, we'll be using the capital letter T to represent the generic data type that we're going to be working with. We would create our data field and make it of type T. Our constructor would accept a parameter of type T. Our accessor method would return a value of type T. And our mutator method would accept a parameter of type T. If we wanted to create a class that's similar to the earlier one, we would place string inside angle brackets when we instantiated our class and pass a string as a parameter to the constructor. But now we could also create a class that would hold points as the data field and pass the constructor a new point. In this instance, the class SumClass would be able to work with points in the same way it worked with strings in the earlier example. Now, a generic data type represents a class type, not a primitive type. If a client wants to use primitives in our generic, the client should use a wrapper class in the definition. For example, here, if we wanted to have an array list of integers, we would need to instantiate an array list of the integer wrapper class. Similarly, if in our previous example we wanted to have our SumClass hold doubles, we would instantiate it with the wrapper class double. Some of the rules for classes that are of a generic type, we use the type parameter T. The only place we need to use the type parameter T in angle brackets is in the class's header. The T in angle brackets does not follow the name in the constructors or in any of the methods. We use T as a data type inside our class definition, and this T can be used as a data field data type, the type of method parameters, method return values, and local variables inside our methods. The class name followed by the angle bracket T is the data type of the class name. So we have a class name, in our case SumClass. The data type is SumClass string in our first example and SumClass point in our second example. Let's look at some sample generic class types. First, we have the class ordered pair. It'll be a generic type class that holds pairs of objects that can have their orders changed. When we define our class, it's not important to us what types of objects the client will want to store and change the order of. The client can decide that when they instantiate our class. We want to provide code that will allow them to set the two objects that will be stored in our class, and then another method that will change the order of those two objects. So we have two data fields of type T, first and second. We have a method setPair that has two parameters of type T. It sets our first data field to be the value of the first parameter, and it sets our second data field to be the value of the second parameter. Then our method changeOrder changes the order of the two fields. We create a local variable temp that's of type T. It holds the value of our private data field first. Then we assign first to be the value of the data field second, and then second to be what's stored in temp. And we have a toString method that will display the values that are stored in each of our data fields. Because every class is a descendant of the class object, they all have a toString method. So whatever our data type T turns out to be when the client instantiates our class, we should be able to display those data types. Let's look at some sample code that will test our class. First, we'll create a new ordered pair object of type string. We'll set the pair to be apples and oranges. We'll print them out in the current order. Apples should be first, followed by oranges. Then we'll call our changeOrder method, and then we'll print them out in the new order, and we should see oranges and apples. Next, we'll create two name objects, Tweedledee and Tweedledum. We'll create a new ordered pair, but this time we'll set the type of our ordered pair to be name. We'll then set the pair of objects to be Tweedledee and Tweedledum. We'll print them out in the current order. We'll change the order and print them out again. When our code executes, we should see apples, oranges, followed by oranges, apples, then Tweedledee, Tweedledum, and then after changeOrder, Tweedledum, Tweedledee. We can also have interfaces with generic class types. We would declare an interface with a generic class type similar to how we declared our classes. Then, when we implemented the interface, we would implement it in a similar fashion to how we implement other interfaces. There are times when we may want to have the current class be the type that's implemented in the interface. For example, when we implement the comparable interface, we should implement the current class as the data type of the comparable interface. That can be a little complex, though, when the class we're looking to implement the comparable interface is itself a generic type. If we wanted to have our class, some class that's a generic type, implement the comparable interface, we would need to put the entire class name and the generic type declaration inside the angle brackets for comparable. And this is how the statement would look.